You're looking live at Launch Pad 39A, where in just a few minutes, SpaceX will begin fueling its Falcon 9 rocket. At the top is the Blue Ghost Lunar Lander, built by Firefly Aerospace with NASA payloads on board. Hello and welcome everyone to the Kennedy Space Center in Florida. I'm NASA's Daryl Nail, and with us today throughout the launch broadcast is Spacecraft Program Director for Firefly, Ray Allensworth. Ray, so good to have you here today.
Yeah, thank you. I'm so excited to be here.
You're going to have all the knowledge and insight about this entire thing as we go along, so we appreciate that. Liftoff of the Blue Ghost lander is scheduled for 1:11 a.m. Eastern Time and 39 seconds for the detail-oriented. They are currently working no issues and things are good for launch. And if everything goes according to plan, that lander will complete its journey 45 days from now with a landing in Mare Crisium. That's near the Sea of Tranquility. And if that sounds familiar, well, there's a good reason. That is the landing site for Apollo 11 in 1969. Firefly Aerospace, an American company based in Cedar Park, Texas, just north of Austin, designed and built the lunar lander that will carry, among other things, 10 NASA commercial lunar payloads, or CLPS, to the moon's surface, and that's the most that any CLPS mission has taken to this point. Now, we'll explain what each of those instruments do throughout the broadcast, but first, we need to catch a ride with SpaceX and Firefly's Blue Ghost Lunar Lander. We're going to get an update from SpaceX in just a moment. Let's start with you, Ray, though. What's your team doing? What has your team been doing as you've been leading up to this moment just before liftoff?
Yeah, so the team, there's a few different things that are going on with the team. We have one team locally here in Florida, and actually about an hour ago, they provided the go to SpaceX, saying that Firefly Blue Ghost Mission 1 is ready for launch. And we have our primary team in Cedar Park, Texas, in the Mission Operations Control Center, and they're really standing by. The lander is powered off at the top of the Falcon 9 rocket, and we're just in anticipation of launch.
Now let's get a closer look at the moon-bound lander. Here's Ray with an overview of Blue Ghost.
Firefly's Blue Ghost lunar lander was designed for stability. It's about 6.5 feet tall and 11.5 feet wide, so it has a low center of gravity and a wide footprint. Blue Ghost has a robust communication system with 1 X-band antenna and 3 S-band antennas that enable HD video transmission from the lander to Firefly's Mission Operations Center in Texas. The lander has 3 solar panels to help power Blue Ghost and our 10 NASA payloads during transit and on the lunar surface. For propulsion, Blue Ghost has 8 RCS thrusters, or reaction control thrusters, that Firefly designed and built in-house. These thrusters help maintain the lander's orientation during maneuvers and independently perform the final descent by pulsing for a soft landing. We have 12 attitude control system thrusters that help point the spacecraft in the right direction. These are actually the same ACS thrusters we use on our Alpha rocket and Electra orbiting vehicles. Blue Ghost has 1 main engine that provides high thrust for our lunar orbit insertion and braking burn prior to landing. The lander has 4 propellant tanks that carry our hypergolic fuel and oxidizer. We have 2 pressurant tanks that carry our helium. Blue Ghost is equipped with 49 struts that connect our upper and lower panels to provide a rigid structure. These struts were built in-house using the same lightweight carbon composites we use on Firefly's launch vehicles. Blue Ghost has 4 carbon composite legs and foot pads that utilize crushed core honeycomb to absorb shock and stabilize the lander as it touches down on the lunar surface. Our foot pads have contact sensors on the bottom that signal engine shutdown upon landing. We have vision navigation software that supports landing by identifying potential hazards on the moon, such as rocks and craters, before determining the safest landing site.
Firefly's Blue Ghost Mission 1, Ghost Riders in the Sky, is delivering science and technology to the moon through NASA's Commercial Lunar Payload Services Initiative. This allows NASA to buy lunar delivery services from American companies for our payloads. In turn, those payloads will help advance science exploration and the commercial development of the moon. The Ghost Riders mission includes approximately 60 days of payload operations, most of which will be spent transiting to the moon. And then those 10 NASA payloads, they'll have about 2 weeks on the surface of the moon to perform their tests, experiments, and other activities. Let's turn our attention now to the rocket that's going to help Blue Ghost get to its lunar destination. Joining us live is Jesse Anderson at SpaceX in Hawthorne, California. Jesse.
Thanks, Daryl. Last year, SpaceX was honored to launch the IM-1 mission, the first commercial lunar lander to touch down on the moon. We are excited to partner with Firefly for another NASA delivery to the moon as part of the agency's Commercial Lunar Payload Services initiative. This is a special mission for SpaceX today because we are launching not only one, but 2 lunar landers. And we'll share a little bit more about the secondary payload in a bit. And coming soon, SpaceX will launch NASA's IM-2 Nova-C lunar lander mission, also part of the Commercial Lunar Payload Services initiative. Also on the manifest this year are NASA's Punch and Spear X missions, as well as the return of Crew 9 and the launch of Crew 10, just to name a few. Now, it's going to be an exciting year for NASA missions.
The launch out sequence has started.
Firefly's Blue Ghost Mission 1 marks our 8th launch of the year after a record-breaking 2024 where we launched 134 Falcon missions. Also last year, our Dragon spacecraft delivered several missions to and from the International Space Station, including 2 cargo missions, CRS-31 and CRS-30, and 3 human spaceflight missions, Crew 8, Axiom 3, and Crew 9, which is currently still docked at the station. Now, coming back to today's mission, we are now at T-minus 34 minutes from liftoff. And while the countdown continues, let's take a moment to meet the vehicle that will be taking these payloads to space today. Falcon 9 is a reusable 2-stage rocket and the first orbital-class rocket capable of reflight. Since first taking flight in 2010, Falcon 9 has launched more than 400 times, including nearly 350 reflights, proving reusability is essential to sustain more advanced and deeper space exploration. Reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of access to space. And speaking of reusability, this is the 5th flight for the first stage boosters supporting today's mission, which previously flew NASA's Crew 9 to the space station, RRT-1, and 2 Starlink missions. And after it completes its mission today, we will once again look to land and reuse the booster on a future flight. Now, this time the booster will return and land on our drone ship. Just read the instructions, which is currently on standby in the Atlantic Ocean. The first stage, which is the tallest portion of the vehicle, provides 1.7 million pounds of thrust thanks to its 9 Merlin M1D engines. Named after the Millennium Falcon from Star Wars, the 9 in Falcon 9 actually refers to those 9 engines. The second stage is powered by a slightly modified engine called the Merlin Vacuum or NVAC engine. Now, this engine has a larger nozzle, which allows the second stage to perform more efficiently in the vacuum of space. The first stage gets us out of Earth's atmosphere and into space, while the second stage takes the payload to its targeted drop-off orbit. Now, the large barrel structure with the pointed nose cone at the very top of the vehicle is the payload fairing, and it's composed of 2 halves made up of carbon composite material that come together to protect the payloads until we're in the vacuum of space. We'll be attempting to retrieve the fairing halves once again with our recovery ship, Bob. Both halves of the fairing flying today are flight proven, with one side flying for the 20th time and the other for the 12th time. And there you can see on your screen the Blue Ghost lunar lander there, integrated to Falcon 9's second stage in preparation for launch. And you can't see it, but there is a second payload in the photo, iSpace's lander Resilience, which we'll talk about a little bit more later on in the show. Now, Resilience is encapsulated in the payload canister, which is just under Blue Ghost. This is to protect Resilience from the spacecraft above it during launch. Now, when the rocket launches, the canister takes the launch load of the Firefly spacecraft and their payload adapter and transfers it to the rocket structure. Now, it continues to be a smooth countdown. Weather is holding steady, and we're looking good for an on-time liftoff. So while we wait, let's check back in with Daryl and Ray.
All right, Jesse, and our hearts go out to everyone at SpaceX who's been impacted by the wildfires in California, and everyone who's working this mission today and pulling it off. Despite those challenges, we greatly appreciate it. All right, joining me now is Firefly CEO Jason Kim. He's here to talk this mission and what lies ahead for the aerospace company. Jason, you've got decades of experience in the aerospace industry, but you've only been with Firefly for a little more than half a year. How's it been going for you so far, leading this company?
Well, it's funny you say that. I actually was a customer of Firefly on the Space Force's Victus Nox mission we launched a 24-hour notice mission back in September of 2023. So I got to know the team members. I was just really impressed with everybody at Firefly. It's a very bold team. It's a can-do spirit, and very exceptional in terms of engineering, rocket engines, carbon composites. I can just go down the list.
Right. Very impressive in terms of what the company can do, as you say, but Firefly does have the opportunity here to be the first company to soft land on the moon. What gives you, as CEO, confidence that your team's ready to pull that off?
Well, I've been through many different high-stakes critical mission operations campaign. It starts with a great launch, so we've got a really reliable, great partner for the launch. But once we separate it, it's all on Firefly, and we've got a great design. It's a great design with margins built in, good parts selection from a great supply chain, and we're very vertically integrated as well. And then I would say that each subsystem is qualified with many hours. The whole lunar lander is qualified. We did the environmental test at JPL, so our hearts and minds go out to everyone in Los Angeles and at JPL. And then, it's down to the people. Our people, our Fireflies, they've rehearsed for many, many hours. They've done dozens of simulations. Our team is back in Cedar Park. They're ready to go. They've been training really hard under Ray's leadership, and they have trust and confidence in each other. And at the end of the day, it's the people that are going to make this successful.
And there's an added component to this that I'm wondering if you can share with us. You shared this in a press conference recently, that you talked to the two companies that preceded you in attempts in going to the moon, Astrobotic and Intuitive Machines. You were encouraged to call those CEOs and find out what lessons they had to share. Can you share what they said?
Well, first of all, it's something that I wanted to do. That's just my style. I love competition, but in the big scheme of things, we want the CLPS program to be as successful as it can be. I talked to Pam Melroy, who I respect and I've known for many years, and she gave me that advice. You ought to talk to each of the CEOs and find out more. And so that's what I did, and they were very cordial. They took my call. We had great conversations. The number one thing that they would both recommend and advise me on is for our team to be transparent. Open and transparency is really key to get all the support that you can get from the whole world, the nation, NASA, everybody. Secondly, we've looked at all the missions that came before us. It's really hard to do space missions. Going to the moon is even harder.
It is.
And so it's challenging to do that soft landing, as you know. But our team has looked at systematic things that have happened in the past, looked at, the hardware and software. And our design it goes back to the design is a great design with margins. Did tons of testing, both in environmental testing as well as air testing, and the actual crumple zones that we have with our pads. That's gone through different angles of testing, geometries.
A thorough testing campaign.
Very thorough.
And probably don't need that shamrock on your lapel after all, because the team's been doing so well. Hey, Jason Kim, appreciate you being here. Thanks for coming on. And
Thank you.
Good luck to you today.
Yeah, go Blue Ghost.
All right. Firefly started with about half a dozen employees. Now the company has over 700. Ray has been there since day one, and she's going to show us how the Firefly team got through the last leg of Blue Ghost's journey, the rigorous testing campaign. Let's take a look.
Over the past 3 years, our ghostwriters have navigated through major key milestones. The initial phase centered on design qualification. Our engineering team conducted comprehensive analysis of the lander's structural and functional requirements. We then shifted to subsystem testing. We validated carbon composite structures on the test stands, verified the landing navigation system on a simulated lunar surface at our rocket ranch, and evaluated landing performance through nearly 100 drop tests. For our NASA payloads, we performed detailed fit checks to confirm compatibility with the lander's design specifications. We began the lander assembly process by integrating our fluid lines, COPV tanks, and avionics with our structural assembly. The NASA payload teams then traveled to Texas to integrate their components onto the lander. Following this, propulsion system integration involved mounting the main engine and 8 Spectre thrusters to the lander. Next, we wrapped the lander with MLI, or multi-layer insulation, to protect its systems from extreme space temperatures. The fully integrated lander was transported to NASA's Jet Propulsion Laboratory for comprehensive environmental testing, subjecting the spacecraft to simulated space and lunar surface conditions. Simultaneously, we began mission operations training, conducting over a dozen mission simulations from our Mission Operations Center in Cedar Park, Texas. These exercises allowed our team to practice operational scenarios and refine mission protocols for game day. Upon returning from JPL, we performed final subsystem checkouts and inspections of the lander, verifying all lander systems and configurations were ready for flight. Finally, we shipped the lander to the Cape, preparing for its ultimate journey that begins today.
Once the Blue Ghost lander gets to the moon, there are 10 instruments on board that will play a key role in navigating and studying the lunar surface. Joining us now is Mike Selby, who is the mission manager for 2 of the payloads, LMS and Lister. So let's start it off with LMS. That stands for Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity. That's a doozy.
It is.
It measures the flow of heat originating from the interior of the moon. So, Mike, why is that important?
So it's important to learn about how the moon has evolved over time. So Lister is a pneumatic drill that is going to use compressed air to drill down in half-meter increments, hopefully to a depth of 3 meters in total. But in those half-meter increments, it's going to deploy a probe that will make thermal conductivity measurements to help determine how the moon was formed.
And it's going to drill just like we see in this video right here.
Absolutely,
it's
yes.
Kick up a lot of regolith.
Kick up a lot of regolith, absolutely.
All right, and as it goes down and drills in, it's going to get those temperatures. Let me ask Ray, how do you integrate a drill underneath your lander?
Yeah, so the drill was really fun, definitely a team favorite. It's one of the payload it's mounted on the bottom deck of our lander, and it's facing the lunar surface. So some of the other payloads are looking up, out. Lister is looking down so that it can do exactly what Mike just said, drill into the lunar surface.
All right, let's go to LMS now. That is the Lunar Magnetotelluric Sounder, or LMS. It measures the natural variations in the electric and magnetic fields from the solar wind and Earth's magnetosphere to determine the electrical conductivity of the moon's interior. All right, well, so we're looking at it now.
Yes, and so what you can see there are the remote electrodes that are basically an electrode with wire around it, and they're going to be ejected, 4 of those from the lander on 90-degree increments, and so the opposing pairs will operate kind of like a voltmeter, making those electrical measurements of the moon.
Right, and there's 4 of them. It looks like they look like they're about the size of a pickleball.
That would be correct. Yes.
Or softball.
Yeah, and they'll be deployed hopefully about 60 feet out from the lander.
That's amazing. So Ray, if these things got to kick out from the lander, how did you coordinate where they were going to go?
Yeah, so we talk about these 10 payloads. There's 28 different components, and this is a great example of that. So these probes are mounted on the edge, and as he mentioned, they'll shoot off the side of the lander, and then there's also a mast on the top deck that will shoot up. So there's going to be communication from the probes on the lunar surface up to that mast. So it's very interesting. A complex arrangement, but we're going to get some exciting data from it. Absolutely.
Mike Selby, thank you so much for coming and joining us today.
Thank you.
And good luck. All right, for explaining those NASA payloads, we appreciate that. We're going to go back now and check in with the rocket with Jesse Anderson live at SpaceX in Hawthorne, California. Jesse.
Thanks, Daryl. And that was so cool to see how interesting that NASA payload is going to be. Very excited to see, what data we can gather from that. SpaceX is part of the Artemis campaign, which includes clips that will further lunar exploration with NASA. At our headquarters in Starbase, Texas, we're continuing to rapidly build and test Starship, which will enable us to send large amounts of cargo and crew to the moon, Mars, and beyond. 2024 was a huge year for Starship, and 2025 is going to be even bigger. We've completed 6 test flights so far, and 4 of which were last year. And we're looking to dramatically increase the number of launches of Starship this year with tons of exciting firsts coming, like in-space propellant transfer and our first attempt to catch the upper stage of Starship. Starship had some absolutely mind-blowing moments in 2024, most notably the first booster catch, which saw the Super Heavy booster return to the launch tower to be caught out of mid-air on the chopsticks, a major milestone to the path of full reusability. These flight tests are critical for iterating towards a fully operational vehicle because the more we fly, the faster we learn. Development and manufacturing of Starship takes place at Starbase, one of the world's first commercial spaceports designed for orbital missions. Many new buildings and facilities, including the new launch tower and the 1 million square foot Star Factory designed with the goal of producing hundreds of ships a year, were built at Starbase
Stage 2,
in
RP1 mode
2024.
complete.
There's tons of work still to be done as Starbase continues to grow and transform into the gateway to Mars. And in addition to all of that, construction is underway at Cape Canaveral's Launch Complex 39A, where an additional Starship launch tower will be coming online. There's so much to look forward to in this era of space exploration, and we couldn't be more proud of our work with NASA to help humanity go beyond low Earth orbit again. But back to today's mission, let's learn more about Payload, iSpace's Resilience lander. For its second mission to the moon, iSpace aims to achieve a soft landing on the lunar surface, deploy its proprietary micro rover named Tenacious, explore the moon's surface, and collect samples. Now, during the journey to the moon, the lander will conduct a lunar flyby, the first by a commercial lunar lander. And after its 4 to 5 month journey, Resilience will set down in the Mare Frigoris, where it will explore the lunar surface. Resilience is part of the Hakuto R lunar exploration program, which represents iSpace's first 2 lunar missions. Resilience is carrying 6 payloads, including Tenacious, the first lunar rover completely designed, manufactured, and assembled in Europe. And if successfully deployed, it could be the first commercial rover to explore the surface of the moon. For a bit more on Resilience, we have a few words from iSpace.
After more than 100 days in space, Hakuto Mission 1 had ended. The voices of support that we received from all over the world gave us the confidence to not quit the lunar quest. And what we learned throughout our first mission was invaluable. Every technical issue solved, every struggle overcome, every bit of information analyzed, all preparing us for our next move. Today, we're going back to the moon. Improving and optimizing our processes, we have confidence in our ability to carry out this second mission successfully. We work with governments, agencies, and numerous commercial customers, both with and without experience in space, to bring new technologies, businesses, and perspectives to the moon by providing transportation and data services. iSpace is different because it's our vision to expand human activity beyond Earth and to create the future cislunar economy. Today, we prove our resilience as we launch Hakuto Mission 2, Venture Moon. On this mission, we go beyond lunar landing and aim to explore the moon's surface with our Tenacious rover. We are iSpace, and with a global team, we're building the cislunar economy. On today's mission, we carry 6 payloads ready to bring technology, science, art, and culture to the moon.
We are committed to secure humanity's future on Earth and beyond.
We offer an entry point into the cislunar market for everyone who is ready to join us on this amazing venture.
For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. Preparations for Artemis 2 are underway, and we have more on that in the Moon Minute.
Hi, I'm NASA astronaut Victor Glover, pilot of the Artemis II moon mission, and I'm here at the Vehicle Assembly Building at NASA's Kennedy Space Center in Florida, where behind me, booster stacking is beginning for the Artemis II rocket. Mission progress got a big boost recently when technicians with the Spaceport's Exploration Ground Systems team inside the VAB began stacking the first components of the Space Launch System rocket, the solid rocket boosters. 10 segments arrived by train to Kennedy in September of 2023, followed by extensive testing and inspections to prepare for stacking. Technicians inside the VAB are using the massive overhead cranes to stack the segments one by one onto the mobile launcher, which will be used to process, assemble, and launch the SLS rocket. Once all 10 segments are stacked on the mobile launcher, 5 on each side, the boosters will then help support the remaining rocket segments during final assembly, including the core stage and the Orion spacecraft that will take Reed, Christina, Jeremy, and me around the moon and back. The 177-foot-tall twin solid rocket boosters will provide 7 million pounds of thrust during liftoff of Artemis II. That's a look at your Artemis Moon Minute.
Time now to tell you about another one of NASA's 10 lunar payloads on this mission. Next up is the the EDS, Electrodynamic Dust Shield, which uses an electric field to move harmful lunar dust off the surfaces in need of protection. And here to show us how this payload works is the principal investigator, Dr. Charles Bueller. Are you ready for some show and tell, folks? This one's going to be fun.
That's right, I got some props here to share.
All right, first of all, talk about EDS. What is it and why do we need it?
The EDS is a system developed here at KSC for the last 20, 25 years or so.
Wow.
To lift and remove dust from surfaces without any moving parts, gases, or fluids. And we incorporated our EDS technology into various substrates to do just that.
And that's important because this regolith on the moon, it's abrasive, right?
It's very abrasive and it is potentially toxic, yes.
So we don't want that on our equipment or spacesuits or anything that's moving. Okay, so how does, you've got this setup here.
Sure.
And to your left, the thing that you're holding there, that's kind of what is encasing your payload, right?
This is actually the spare parts of our payload.
Okay, all right. So explain how that works when it gets on the moon.
So when we land on the moon, a few hours after landing, we deploy a fifth leg, or an SAA, Surface Access Arm, which will deploy 2 instruments, us and Planovac, and it will jettison us separately after that, a few hours later, and we will softly land on the moon like this.
And how are you going to make sure that you get regolith inside there? Because you need that dirt in there. You need it to get dirty.
We absolutely do. So we're trying to focus on 2 EDSs, self-cleaning surface, a glass and a thermal radiator. And what's going to happen is when we land, we have 6 other EDSs that their whole job is to lift dust from the surface and direct it and deflect it onto our EDSs.
Hold that up for a second, Dr. Bueller, because you can see through those little bands, right? What are those? It looks like that the dirt can pass through them.
Those are just electrodes. The same thing in our transparent EDSs.
They can kick up the regolith onto it? Okay.
Okay,
and so now let's show us how this technology works. Once you get it dirty,
once you get it dirty with the reduster, you can show here. So if you have a glass system, a camera lens, or something,
we got a camera.
You can get
overhead.
it really dirty on the moon.
Oh yeah, okay.
And that's bad news.
Yeah.
So you don't want that. So you want to turn on your EDS, and then voila, dust will come
Look
off.
at that, just
All
right off
clean.
the surface.
Yeah.
And that is electrical current that's created.
That is an AC square wave signal.
Okay.
Low current.
Now, can we give it a tougher test? Can you really get this? I mean, we can get my 1.5-year-old to come in here and throw dirt. He's very good at throwing dirt. If you need help.
Well, we'll keep adding dust. Why not?
Yeah.
You know.
Hey, it's live TV. What could go wrong? Yeah.
Cover the whole thing. How about that?
Now you're talking.
And what I can also do, once we de-energize that might take a few more minutes. It doesn't take too much longer.
So if that's harmful regolith, literally nothing moving, no moving parts, no gases, and it's just coming off the surface, and it still continues to work it right off.
Yep.
That's fantastic.
And what's nice is if it's on, we can't get dust to stay on it. That's also very useful.
That's fantastic because these little dust particles, as I understand on the moon, as you were just talking, are like little shards of glass. So you don't want that stuff to stick. What do you expect to happen on the moon when you do this?
Now on the moon, we have to polarize the dust, so that takes a little bit longer. So we apply a DC field for a few seconds, a few minutes. And that's based on the resistivity of the dust.
Okay, and Ray, been pretty fun to watch that, happen, and you had to make sure that this had good access to the regolith. How'd you do that?
Yeah, so as he mentioned, we designed this surface access arm, and so when we land on the lunar surface, that arm will deploy down, and then there's a hinge that we very specifically designed to get EDS to flatly land on the surface and get that dust up in it the way it needs to perform its science objectives. So.
And you can kick up a little more regolith if he needs it?
Yeah, well, there's other activities going on the lander that I think will really help get dust on there. You know, the Lister drill will be running. You know, there might even be some dust from landing, that impact kick up a little. So we'll try to get a lot of dust on your payload to help you out.
I appreciate that.
All right, very
We
good.
want to be dirty.
I want one of these for my entire house. And just punch it and all the dust goes away. Then you really have something. We are looking forward to this experiment. Thank you, Dr. Charles Bueller, for being here. Thank you for the demonstration. And Ray, appreciate your insight on how you integrated into the payload. That's great.
All right, well, thank you very much.
All right, time now to tell you about another one of NASA's 10 lunar payloads. We're going to have so much more of these lunar payloads coming up in the show. We're going to get to that in just a little bit. You may have heard us mention CLPS, which is the Commercial Lunar Payload Services Program, at the beginning of the show. Let's dive a little deeper now into this relatively new NASA initiative.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
And we're getting close to liftoff, just T-minus 8 minutes and 15 seconds until launch of Firefly's Blue Ghost lander on a SpaceX rocket. Ray, the journey to this moment began for you and your team more than 3 years ago.
Yeah, it's been quite a journey getting here. This contract was awarded in early 2021, and so, all this work over the last few years is leading to this moment.
And you've got a pretty big team. Talk a little bit about that.
Absolutely. We have a team of dedicated engineers, operators, technicians, and support staff that have been working tirelessly to make this mission a success. I'm incredibly proud of what our team has accomplished and what we'll continue to accomplish once Blue Ghost begins its road trip to the moon.
And what's your sense of how the team is feeling right now? You've done a ton of preparation. You've been there from the start with these folks getting ready to do this mission.
Yeah, the team right now, I think, is just filled with anticipation, excitement. I was messaging some of them earlier, and I think today it really started to set in, when you see that Falcon 9 go vertical on the pad. So just excited to finally start our journey.
And we're looking live at the Mission Operations Center in Austin, Texas, Firefly Aerospace. You can see the folks sitting there. This is the mission team. This is the team that's going to be there all the way to landing and beyond.
Engine chill has started.
Absolutely. So you can see all of them kind of sitting there. They're getting prepped. They're getting their consoles set up. They'll probably start getting some initial data from that first ground station, but otherwise, with the lander powered off, they're really just waiting for deployment and power on.
Ray, I'm wondering, Firefly, as a company, you've launched before, but this is the first time that you're launching to the moon. Is it different?
I think it's a little bit different. You know, I'm sure the Alpha team, the first time they launch, they feel very similar to how I feel right now. But really for launch, it's a few hours and then your mission's over. For us, this is really just when our mission
Stage
begins.
1,
And
fuel
it
load
leads into
complete.
these 60 days of operations in orbit and on the surface. So it's kind of a surreal feeling. It's hard to explain.
And you get to look up at the moon at night and say, we're going there.
Yep. So I think all of us kind of started looking at the moon a little differently. You know, leading up, the engineers would text us, you know, 3 full moons till we launch, 2 full moons till we launch. And so you look up at night and you get filled with excitement.
Well, we are excited as well. We're going to go out and watch that launch. In the meantime, there's the moon. There's where you're headed. Let's send it back to SpaceX in California as they walk us through the final moments of the countdown.
Thanks, Daryl. At T-minus 5 minutes and 40 seconds to liftoff, all systems are currently go for non-time liftoff at Launch Complex 39A at Kennedy Space Center. And the moon was looking great, but we were waiting for a call out for the strong back retraction coming up here shortly. What's going to happen is the clamp arms around the top of the second stage, which is just below the fairing, will begin to open up. Once those clamp arms open up, then we'll begin to move the strong back away, slightly away from the vehicle. And that process will take about 20 seconds. Vehicle, the TE or transporter erector will be just about a couple degrees away from the vehicle. And then at T0, we'll move it about 45 degrees above the pad deck.
Pressing for strong back retract.
And that will make the way for liftoff for Falcon 9. And we did hear that call out that we are preparing for strong back retraction. That should be coming up here in about 20 seconds. Now, the strong back is that vertical structure just behind the vehicle that you see there on your screen.
Strong back lower has started.
And there's that call out that the strong back retraction has begun. Now, again, what you're going to see is those clamp arms just below the fairing are going to begin to open up. And once they're fully open, that'll make way for the transporter erector to move away from the vehicle. Now the TE, or the transporter erector, is carrying the propellant, electrical, and gas lines to stage 2, as well as the payload. And there you can see on your screen that those clamp arms are now opening up. This is a good view here because you'll be able to see that TE start to move away from the vehicle. It's pretty slow, but you should be able to see it here in a few seconds. And there you can see that TE starting to move away from the vehicle. And once Falcon 9 commands for liftoff, hydraulic cylinders pull the strong back even further away, again to that position about 45 degrees above the pad deck. Now we are coming up on liquid oxygen loading completion at the T-minus 3 minute mark. Now, for some reason,
Stage 1 LOX load complete.
There's that call out we were waiting for. Stage one liquid oxygen loading is now complete. If for some reason we do not launch today, we do have a backup opportunity tomorrow, January 15th at 10:09 p.m. Eastern Time. Currently, weather is green and the range is ready to support a T0 of 10:09 p.m. Eastern Time. And the landers continue to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. Next coming up will be at T-minus 2 minutes. We should hear the call out for propellant loading.
Stage 2 LOX load complete.
Right on time. That is stage 2 LOX load complete. That means propellant loading is now fully complete on Falcon 9. The vehicle is now fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. And just a correction, it is 1:11 a.m. Eastern time for liftoff tonight.
Gas launch closeouts has started.
Now that propellant loading is complete, we should begin to see venting coming from the transporter erector. That is just clearing out those propellant lines from the TE in preparation for liftoff.
Falcon 9 is in startup.
Good call out. This means that the Falcon vehicle's internal flight computers have taken over the launch countdown. We're now just waiting for the final go from the launch director.
LD, go for launch.
And great news, we are go for launch, so let's watch as Falcon 9 takes our 2 lunar payloads out to space.
T-minus 30 seconds. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Firefly, go iSpace, go Falcon. Vehicles pitching downrange.
T plus 30 seconds into launch, Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center. Now the vehicle is going vertically, but it will begin to move horizontally. We're going to gimbal those.
Falcon 9, power and telemetry are nominal.
We're going to gimbal those engines. We're still going up, but now
Engine air pressure is nominal. Vehicle is supersonic.
We'll be moving horizontally, and that helps the vehicle get into orbit and avoid being pulled back down to Earth. And we are coming up on max Q. This is the largest structural load that the vehicle will see during ascent.
Max Q.
There's that call out. We've passed through max Q. And we do have a few events coming up in quick succession. That'll be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we will shut down all 9 of those M1D engines that you see there burning bright on your screen. That prepares the vehicle for stage separation. That's when the first and second stages separate from each other, and the first stage will begin to make its way back down to Earth, while the second stage carries the payloads and continues with its journey with SES-1, or second stage engine start 1. And that's where we will ignite the MVAC engine on the second stage. And shortly afterwards, we will have SECO, where the vehicle will coast. So we are coming up on those 3 events that I just mentioned: MECO, stage separation, and SES-1 in just about 20 seconds from now. Some really cool tracking views here of Falcon 9 and those 9 Merlin M1D engines burning bright there.
MECO, stage separation confirmed. MVAC ignition.
And great views. We watched as we shut down those 9 Merlin M1D engines, stage separation, and now you can see there on your screen that MVAC engine has ignited, again carrying the 2 lunar landers aboard Falcon 9's second stage. And there on your left-hand screen, you can see that the first stage is deploying its grid fins. Those hypersonic grid fins will help guide the vehicle back down to Earth. And in about 15 seconds or so, we will also have fairing deploy. We have the fairing protecting the payloads through ascent. But once we're in the vacuum of space, we no longer need that protection, so we will jettison those fairing halves.
Fairing separation confirmed.
And a really cool view of the payloads encapsulated in those fairing halves, the fairing halves deploying. We will once again attempt to retrieve these fairing halves once they make their way back down to Earth. And in a few minutes, we will also have a couple more burns for our first stage to prepare it for landing on our drone ship. Just read the instructions. Now we are T plus 4 minutes and 10 seconds into today's mission. We're currently in the first of 3 planned MVAC burns. Around T plus 6 minutes, you should see on your screen the first stage's entry burn. Now that entry burn is where we ignite 3 of the Merlin M1D engines, and that's going to be the E9 engine plus the E1 and E5 engines. Now that helps slow the vehicle down as it's re-entering back into the Earth's atmosphere. Now, the reason why we slow down the vehicle is to reduce the re-entry forces, which helps us recover and reuse the first stage booster. So far, everything is looking nominal. Stage 2, still carrying our lunar payload and on a nominal trajectory. Now again, the first stage vehicle is making its way back down to Earth. We're about 45 seconds away from the entry burn beginning. And just as a reminder, the first stage booster that is supporting today's mission will perform this entry burn for the 5th time. Falcon 9 is the world's first orbital class rocket, reusable rocket, and this is important because reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. So we do have that entry burn coming up just about 10 seconds. Again, that will be 3 engines reigniting for just about 20 seconds or so.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
There's that call out, and on your left-hand screen, you can see that those engines have ignited. Again, helping to slow down the Falcon 9 booster as it's making its way back down to Earth.
Stage 1 entry burn shutdown.
And there we heard the call out as well. As you can see that the engines have shut down. That concludes the entry burn for the Falcon booster. Coming up next in about 1 minute will be SECO. That is second stage engine cutoff. And that'll basically be where we shut down that MVAC engine and allow the stage to coast with the payloads.
Stage 2 is in terminal guidance.
As the vehicle is making its way towards its targeted drop-off orbit for each of the lunar landers. And just shortly after we have SECO, we'll also have the landing burn startup on the booster. So we will have a couple events happening back to back.
Stage 2 FTS is saved.
Stage 1 transonic.
For the landing burn, we reignite the center E9 engine. And again, that slows the vehicle down just in time to touch down for landing. And we have SECO 1 coming up, as well as a landing burn in just a few seconds.
SECO.
Stage 1 landing burn.
Nominal orbit insertion.
Full view of first stage, touching down for landing.
Landing leg deployed. Stage 1 landing confirmed.
And there you could see on your screen, the Falcon has landed on Just Read the Instructions. That marks SpaceX's 398th recovery of an orbital class rocket, and that includes first stage landings for Falcon 9 and Falcon Heavy. Now we're just waiting for confirmation of good orbit. Again, we have had SECO, that is second engine cutoff 1 for that MVAC engine. And we are just waiting to confirm good orbital insertion. And we have confirmed good orbital insertion. Now the mission isn't over just yet. Coming up next, we have the second burn of our MVAC engine, or SES-2, on board the second stage around T+58 minutes. And then that'll be followed by payload deploy. So until then, we're gonna send it back over to you, Daryl, at KSC.
All right, thank you very much. If you're just joining us, we are just into the mission here, T+10 minutes and 30 seconds into the flight of the Falcon 9 with the Blue Ghost riding aboard. And it was, as you can just hear, a nominal orbital insertion. Great news. We just witnessed it live right here from the Space Coast at Kennedy Space Center. And on board are 10 NASA payloads headed towards our moon. We have Ray Allensworth, who is here, the spacecraft program director. You and I were just out there watching it live outdoors, just 3 miles away. How'd that feel?
I can't stop giggling. No, I mean, it's one thing to watch a rocket go. It's another thing to know that your payload's on the top of it. Right. So it was incredible. It was perfect.
I heard you say, bye, honey.
Kind of wave goodbye.
Yeah. When you work so long on something like that, I can just only imagine how that felt for you. Thank you for trying to put it into words. Now, looking ahead a little bit, we're going to have a burn, a second stage engine burn that's going to help complete its trip to get you where you need to be around the Earth and into that orbital insertion. And then we're going to deploy at 1 hour and 5 minutes. So we're looking at about 55 minutes from now. And there's a lot more work to do. So make sure you stay with us. We are on top of it here with our team, watching it in the sky and tracking it along its path. And we're also going to nail that acquisition of signal right after it separates. So we're going to be expecting that about 6 minutes after launch vehicle separation. That will be an amazing moment, and you'll want to see Blue Ghost separate in near real time from the second stage of the rocket because it's a phenomenal view. All right, we're continuing to track, and if everything goes as planned, in 45 days, the Blue Ghost lander will land at Mare Crisium, a large, dark basaltic plain in the northern hemisphere of our moon. The location is near the Sea of Tranquility, the landing site for Apollo 11. It's also near Taurus Littrow, the Apollo 17 landing site. Ray, NASA chose Mare Crisium as the landing site for a good reason.
Absolutely. The landing site was chosen by NASA because it supports the goals of our 10 NASA payloads that will gather critical data about the moon's regolith, geophysical characteristics, and the interaction of the solar wind and the Earth's magnetic field. The landing site also allows us to capture the lunar sunset after Firefly operates for a full lunar day, which is about equivalent to 14 Earth days. We'll be studying a unique phenomenon seen by Eugene Cernan during his final steps on Apollo 17, where he observed a horizon glow as the lunar dust levitated on the surface. On your screen is a sketch Cernan made of the event. Firefly is set to capture this phenomenon during the lunar dusk conditions and further prove what Eugene saw as the last astronaut to walk on the moon.
And you can see on your screen a live shot right now of the moon. This actually was recorded just a few minutes ago, but this is what it looked like outside when we were looking up. Such a beautiful shot, and big thanks to our camera crew for grabbing that. And if you look closely, you can see where Blue Ghost is heading, that landing site. It's in the 12 o'clock position. Correct me if I'm wrong.
No,
right
absolutely,
in the clock,
right there.
And there it is, right at the top of your screen, that basaltic plain, that basin there. And what a beautiful shot. Blue Ghost is on its way. With us now, the Associate Administrator of NASA's Science Mission Directorate, Nikki Fox. Well, you saw it live in person as well, Nikki. And
I did.
Beautiful shot of the moon there. It's all coming together.
I know. I had as it was going up, I had the urge to say, that way. There's the moon, that way. It was a fantastic launch. Something really special about an instantaneous launch as well. You know, that countdown goes, and you know it's going to happen. It's got to be right at that moment. Yeah, so a beautiful sight. Congratulations,
Thank
Ray.
you.
You must be so, I know exactly how excited you are right now. It's amazing.
I'm taking in all the moons now.
I did. I mooned out for you guys today.
You sure did.
I did, yes.
Oh,
yes.
It looks lovely. Well, let's talk a little bit of science now. How was the science and the tech on board this particular mission inspired by NASA's Apollo 11 mission?
Yeah, I mean, we learn, the great thing about NASA and about NASA science is we learn with every single mission that we do. And so, of course, we learned so much about the experiences of our astronauts on the moon. And, you mentioned before that the regolith is a big challenge. It's very sticky, and it's very tacky, and it kind of sticks to everything. And so we actually have a couple of experiments on there. One is going to sort of look at just how tacky that dust is. It's going to look at different surfaces and see how much that regolith sticks to it. And then we have another one that's a super cool demonstration that's going to try and see if you can shake the dust off. Mm-hmm. It's the EDS instrument, and it's going to put sort of electric currents through, so it's not moving parts, it's not actually shaking it, just to see if you can displace the regolith, and so actually the instrument cleans itself as well. So it's very, very friendly, and so we're going to look at how we can improve the conditions for the Artemis astronauts.
Yes, and we had a wonderful demonstration of the EDS principal investigator showed us how exactly how that dust is going to shake off. Can't wait to see what happens on the moon.
Yes.
Why are we sending robotic missions first before we send human missions to the moon?
I mean, we want to send as much science to the moon as possible. It's such a great place for us to go. It allows us to just learn more and more about the conditions on the moon, about the geophysical conditions, about the solar wind interaction with the moon. We can't wait to get the science up on the moon. That's why we're such fans of the CLPS program. It's like a geological sort of preserved record of what this ancient solar wind is like. You just need to go down a little bit into the regolith, and that's the preserved sort of surface interactions. And of course, it allows us to think about what we want our astronauts to focus on. They will be able to bring back the samples from the moon for us to be able to study, and so to be able to kind of help focus on which samples, what do we want for them to bring back. This is all stuff that we can do with these kind of advanced sorties that we're doing with the CLPS program.
Advanced sorties. Well, I like that. That sounds good. And in this plane, and briefly, it's a basaltic plain. There's a volcanic feature nearby.
Yeah.
Tell me what the relevance of that is, Mons Luttrell, and why you're interested in that.
Well, I think Ray just kind of nailed it. I mean, it's a great place for us to go. It's a region that we think the astronauts will be interested. It's a really great place. Loads of interesting features. The actual area was caused by an impact from an asteroid. It flooded that area full of that lava. It's a very dark lava, very similar to what we have on Earth. It tells us about how the moon was formed, how the early solar system was formed as things were bombarding the moon. So it's just a really scientifically interesting place to go.
And Ray, you appreciate that there's no big rocks, hopefully, in that area, right?
Yeah, we're gonna avoid the rocks. Our software is gonna help us identify the safest place to land, and like you said, avoid those hazards.
All right, very good. Well, Nikki Fox, thank you for joining us today. We appreciate your moons. We appreciate the insight, and we appreciate your levity as always. NASA tends to be a serious place, but you bring the right the right mix of levity and seriousness. Thank you very much.
Thank you so much. Appreciate it. Congratulations again.
Thank you.
All right. Well, it's difficult work to get to the moon. We haven't successfully done it in more than 50 years, but that's going to change. The CLPS initiative is changing that. Let's take a look.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science exploration and technology experiments as possible.
So CLPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank the nut. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely?
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission, and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
All right, we've been going through each of the 10 payloads throughout the show, and now we've got a doozy. 5 of the payloads right now, and that's half of the ones going up to the moon. Joining us now is Dennis Harris, mission manager for those NASA payloads, and appreciate you being here.
It's good to be here.
Let's start now with the Lunar Planet Vac, or LPV, which collects samples of lunar regolith from the surface. This is really interesting. I mean, the name kind of suggests exactly how it works. Planet Vac.
It's like a vacuum. Yeah. They carry up their own compressed gas, blow down on the regolith, collect it, and then put it in a canister. And this is a tech demo, so the canister in the future can be used to return the samples to Earth, or it can be used to send to any instruments on the spacecraft for in situ measurements during the mission.
Yeah, if we wanted to bring it back, we could.
Correct.
And there you see it, Ray, as it's mounted there underneath the Blue Ghost. Tell me how you had to account for this thing, which is touching the regolith.
Absolutely. So this payload, obviously they're a vacuum. They really needed to be in situ, touching the regolith. So it's on the bottom of that surface access arm that we talked about earlier that's also carrying EDS. And so when we land on that lunar surface, that surface access will go down and their sample collection head is right at the end. So it'll press down into the lunar surface and then collect dust onto a sample sorter that we placed on the top deck. So it's another payload with multiple components that we placed kind of strategically to help them accomplish what they need to.
Maximizing that lever arm that you're putting down on the surface
Absolutely.
of the moon. Yeah.
Pack them all in.
Right. Okay. Well, next up is LEXI, the Lunar Environment Heliospheric X-ray Imager. LEXI is a wide field of view, soft X-ray imager that will image Earth's magnetosheath and magnetopause to study how energy from solar wind generates geomagnetic storms and space weather. This one's interesting to me because this is looking back at Earth rather than looking at the moon.
Correct. And as Brian Walsh, the PI, said yesterday, this is going to be the first global measurement of the Earth magnetic field and the interaction with the solar wind.
And we can see in this graphic where they interact. Explain that to us.
Well, this is where the solar wind meets the magnetosphere, and what happens is you see the bright yellow and red spots, they're giving off energy. And so we're going to look at the photons, which happen to be in the frequency of soft X-rays, to see what's going on.
What a unique area to look at that. And I take it, Ray, that it had to go on top, right, in order
Absolutely.
to look up.
Yeah, this payload, very top deck. It's also mounted on a 2-axis gimbal. So this is a gimbal that we really specifically designed. Yeah, you can see it there. So that LEXI can look back specifically where it needs to collect that data. So a pretty intricate gimbal, but I think it was a lot of fun for the engineers to kind of solve that problem to get LEXI pointing where it needs to.
That's cool, that 2-axis gimbal, a solution coming from Firefly. You got to appreciate that.
We do.
All right, well, this instrument that's next is, we have a demo right in front of you. A RAD PC. This is a radiation-tolerant computer system. Dennis, why do we need radiation-tolerant computers?
Well, radiation is a killer for computers. Ionizing radiation could cause a bit flip, could crash the whole system. This particular system is going to use a set of 4 CPUs to kind of count each other and make sure each other's, there has been no single events. And so if it senses one, it puts one of the pads offline, uses the other 3, rewrites this one, puts it back on. And so radiation-hardened hardware is very expensive. And
right,
so
to build a shell around it, that's expensive and it's heavy, right?
It's heavy, and this is 95% commercial off the shelf.
How about that?
And so it's order of magnitude cheaper, and I believe it could be the future of space computing.
Really jump the computing power on the moon in an area that's really tough for computers without adding weight. I like that. That's good stuff. All right, 3 down, 2 to go. Next up is NGLR. This is the next generation lunar retro reflector, right? And it's a target for lasers on Earth to precisely measure the distance between the Earth and the moon. Explain that, how that works right there.
Well, range finding observatory on Earth is going to shoot out a laser pulse. It's going to hit this, and it's going to return it. And the nice thing about the next generation is it's built so it's going to return the ray to where the observatory is going to be. Not where it was, but where it's going to be on the Earth. So this is going to allow us to make precise measurements and watch the surface of the moon as it moves around. And actually, this is a follow-on to Apollo retroreflectors. Some of the same team that put the Apollo retroreflectors on the surface are working this program as well.
That is a fun fact and worth mentioning. In 1969, University of Maryland physicist Doug Curry helped design 3 still-in-use lunar instruments placed on the moon by Apollo 11, 14, and 15. And he worked on this one.
He is the principal investigator, yes, Dr. Curry.
How about that?
It's a lifelong passion for him, and I really appreciate his knowledge.
And you got to work with him on it.
Yes.
Pretty basic in terms of installing this, I would take it?
Yeah, this is our only payload that doesn't have an electrical interface. So this is purely a mechanical interface that is also on the top deck on one of those 2-axis gimbals. So we loved NGLR.
Right, very good. All right, and last but not least, we have the regolith adherence characterization, or RAC. Now, I kind of like this one because of all the different samples that are on board. It's going to determine how lunar regolith sticks to a range of materials exposed to the moon's environment. So there it is. What are all those little, circles on the wheel?
So those are all different material samples. So some are spacesuit materials, some are optical materials, some are Teflon, some are aluminum. As Nikki was talking about, lunar regolith is really not good to work with. And so what we want to help determine here with this experiment is what kind of materials can we use in the future? What kind of changes can we make to, say, spacesuits or the equipment we put on there to help them, you know, live longer and survive the regolith.
And you want to get it dirty, I take it.
This
You
one
want
is
to
the
get-
one, this,
yeah.
much like Rad PC, who wants all the radiation can get, we want all the dirt we can get, so to speak.
So how did you accommodate that, Ray?
So this payload it's not on the bottom deck, well, facing the moon. It is kind of facing outward, though. So that wheel is exposed outward. It's not covered by any of that gold MLI you see on the rest of the lander, so that when we land, anything that kind of puffs up will go and hit those materials, and you'll be able to study how they affect all those.
And if you don't get enough regolith on it, is there anything you can do to help it out?
I think a lot of the other payload ops will help it as well. You know, maybe we'll toss a cold gas thruster their way if they need a little more. We'll play with that. But they should be able to get covered pretty well.
There's literally a negotiation going on right here.
Yeah.
It's like,
Right
okay,
here.
we'll take that, right?
That's a good idea.
Wow, ideas coming out on a live broadcast. I love that. All the work that's been done, you had 5 of these. You must have been pretty busy.
I was. It's very challenging, but it's a new paradigm. And these are low cost, more risk tolerant. And the teams that worked on them have worked hard for the last 4, 5, 6 years. I really appreciate their effort. And yeah, NASA's job is to help them get to the moon and help us all get science.
Absolutely. And Dennis, before we let you go, a human interest note. You told me that you invited your mother, 90 years old, to come watch this launch as something to mark off her bucket list.
Absolutely.
It just happened. How did that go?
Oh, she loved it. Right up front, loved it, especially the sound. She took the video, and she was all smiles.
And she has an engineering curiosity, right?
Right. She was, back in the early 50s, she had a scholarship to Montana State for an engineering scholarship, which unfortunately she couldn't go, but she then jumped into the Navy, came out as an electronics tech. So maybe that's where my interest in engineering comes from.
She must have been proud watching that rocket fly with your 5 missions aboard.
She was.
All right,
Yeah.
Dennis Harris, thank you very much for joining us. Appreciate you taking the time, and good
Thank
luck
you.
with all of the payloads.
And good luck to you guys.
Thank you.
Really looking forward to it.
All right. Well, now we are going to step aside while we await our next big milestones, the second burn of the second stage of the Falcon 9 rocket, and then the separation of Firefly's lunar lander from the SpaceX second stage. Now, we're going to return for that and more in about 20 minutes. We'll have more payloads. There's 2 more left if you've been counting. We're going to talk about those. We'll also see that tremendous video as we watch Firefly hopefully release from the second stage and drift off into space. That's all coming up in a bit. Again, 20 minutes from now. Hope that you'll come back and join us. Take a little cat nap. We'll be right here, and we'll see you then. And welcome back to the Kennedy Space Center, where we are currently awaiting the second burn of the second stage of the Falcon 9 rocket, and then separation of Firefly's Blue Ghost lander from that second stage rocket. It lifted off at 1:11 and 39 seconds a.m. Eastern Time. I am joined by Ray Allensworth. She is the Spacecraft Program Director at Firefly. Been doing a fantastic job. We watched the launch live. It took off. You said, bye, honey. This is a spacecraft you've been working on for so long, and then you saw it take off, and now we've been flying for about 47 minutes. What's your sense of how the team is doing, and how are you doing at this point?
My heart rate's come down a little bit. It's definitely very special to see it go. I think the team now, especially that team back in Texas, really this is where they're locking in. So, you know, we're about to go into payload deployment. The lander's powered off right now, but it will soon start that automated sequence to power on. So this is really where we start. So just a lot of anticipation building.
A shot on your screen now of that team that you're talking about from just outside Austin, Texas, the Firefly Aerospace Mission Operations Center. And the team is all there and, as you say, focused on the next steps. The company is, of course, based in Texas. They developed and built the lunar lander that is carrying, among other things, 10 NASA payloads. And if everything goes as planned, in 45 days, that Blue Ghost lander, which is uncrewed, there are no people on board this is purely a robotic mission. If everything goes as planned, it's going to land on Mare Crisium in the northern hemisphere of our moon. It's an area that, of course, NASA wants to study and was chosen specifically for that reason.
Yeah, absolutely. That place, you know, Apollo has visited there. We also believe future missions will want to go back there. So it's a really important place to go, gather data, and just prepare for what's next.
We still have a few more NASA payloads to cover throughout the show. We've talked about 8 of them. And now, finally, the last 2.
Last 2.
You ready? All right. Let's talk about it. And it starts with LUGRA, an acronym for Lunar GNSS Receiver Experiment, which was developed at Goddard Space Flight Center. LUGRA is one of the very first demonstrations to test GNSS signal reception and navigation on the lunar surface, right? These are satellites going around the Earth, but we're using them to develop location on the moon. GNSS is the Global Navigation Satellite System, which is commonly thought of as GPS. Of course, that's the American Satellite System nomenclature for it. If successful, this would pave the way for operational use by future lunar missions, such as the Orion spacecraft, the planned lunar orbiting station called Gateway, and robotic and human landers. Ray, of course, Blue Ghost is using different navigation to get there, but imagine if you could use GNSS.
Yeah, that'd be really amazing in the future. You know, quite like use your phone, pull up Apple Maps, Google Maps. You want to put in a place, you go exactly there. That's the future of what could happen on the moon.
And that's pretty cool. That would be an advantageous thing for anything going to the moon, right? How did you get this mounted on the spacecraft?
Yeah, so LUGRA is mounted on our top deck. It's on one of those two-axis gimbals. So LUGRA shares a panel with NGLR. And this is a really special payload. This was in partnership with the Italian Space Agency. And so, yeah, we're excited to have that and get it operating.
First equipment for the Italian Space Agency to have on the surface of the moon. We know they are very excited about this. Let's talk about our last payload now, the final one. This one really kicks in right about the end of, right when they were landing, right? As it kicks up a plume. It's SCALPS, and it stands for Stereo Cameras for Lunar Plume Surface Studies. It was developed at NASA's Langley Research Center in Hampton, Virginia. SCALPS is an array of cameras placed around the base of the lunar lander to collect imagery during and after descent. Those images will then be compiled to produce a 3D view of the surface, and not just for the novelty of it. As trips to the moon increase, the number of payloads touching down in proximity to one another will also increase, and you see it there as it's mounted on the Blue Ghost lander, and now you're seeing an animation of it landing. Scientists and engineers, they need to be able to accurately predict the effects of landings and how much of that regolith, which we know is harmful, gets kicked up on instruments and equipment.
Yeah, absolutely. SCALPS is really going to be gathering so much data. It's the only payload that's powered on during descent. And just like you said, is exactly right. It's gathering data. It's seeing the lunar surface, what happens right before, at and after landing. So Scalps has flown before on a previous mission. This is their second time. We're excited to fly them. It's our first time with them, but it'll really inform all those future missions when they go to land on the moon.
All right, very good. Thank you, Ray, for the breakdown. Blue Ghost will deploy in about 15 minutes from now. And Ray, what can you tell us about the journey it's going to take to the moon?
So the journey to the moon is going to be elongated. It'll be 45 days in orbit. And we really want to keep everybody updated with us as we go along this journey. So we'll be doing daily updates on our mission page and our X channel. We'll also be doing weekly updates. And so these will be updates coming from the Mission Operations Center. And we'll release them on Thursday afternoon on our social channels. So we'll really want everybody to kind of go with us on this road trip to the moon.
Video updates from the team, not video of the moon.
Correct.
That will come later, but this will be a really great way for you guys to engage with the audience and show them the progress that you're making.
Absolutely. You know, there are going to be times during orbit and the surface where we'll share photos and videos, but these weekly video updates will really be coming from our Mission Operations Center, from those engineers that are operating the spacecraft.
All right, looking forward to that. Spacecraft separation will be just the beginning for Blue Ghost. Here's more on what we can expect on Blue Ghost's mission to the moon. All right, joining us now to talk about NASA's reaction to the progress Firefly Aerospace has made so far in the Blue Ghost mission is NASA Deputy Administrator Pam Melroy, former NASA astronaut as well. Thank you so much for being here. Well, you were here for the launch. You watched a beautiful launch. Your reaction?
Wow. Well, I think it's easy to forget at a moment like this how much work goes into, how many things have to go just exactly right. So I'm excited. My congratulations to Firefly, to SpaceX, to the NASA team, everybody who played a part in this, including the people who put the instruments on it as well. There's a lot of work to do yet, but it is just amazing to achieve this, and it was such a gorgeous launch.
Right. I mean, beautiful. You had the moon up there, nearly full. It was waning gibbous,
Yes.
97%.
Yes.
Want to make sure we get that right. But yeah, and then you could see it. It was such clear conditions.
Yeah, and I think what's interesting is I've seen so many launches that were going to the space station, and they disappear quickly. They're going up the East Coast, and they're gone. And so the trajectory is just so noticeably different. You're like, oh yeah, this one's going somewhere else. It's really exciting.
It seemed louder than normal because I've seen a lot of launches like you, and it was powerful as well. Well, I want to ask you about a couple of things. There's a lot of hard work ahead. Of course, Firefly Aerospace, as Ray has been telling us throughout the broadcast, it's got some challenges, right? They've got to land on the moon, which is not easy, and that's the nature of this program. So what would you say as part of the leadership here at NASA to the Firefly team about the work they have ahead?
Yeah, well, this is a great moment, but I think what we all know is that you can celebrate a moment and then you have to move on. There's a lot of work ahead, as you pointed out. This is incredibly hard. And I think my message to the Firefly team is congratulations for getting where you are, but keep your eye on the ball because you got a lot of work going. But I think one of the other important messages is we do this as a team. This is a team sport. And so the collaboration within the Firefly team, but also with your partners is really important. NASA has your back. We know that we're all doing things for the first time. So we just have to work together to solve any problems that come, and then we'll be successful together.
Great words. I know that you must appreciate hearing that.
Yeah, no, I think the team back home really appreciates that. They, I think they know that, we're all one team, but it's another thing to hear it, especially in this moment. Because like you said, really their job is beginning now. And, we have to refocus and start our mission.
All right. Thank you very much, Deputy Administrator Pam Melroy, for being here. You are with the outgoing administration. Your time at NASA, we really appreciate your leadership here and all that you've done and coming to these launches and being a part of these launch broadcasts. Thank you very much.
Thank you, Daryl. It's a great way to go out.
Absolutely. Thank you, Pam. All right. Well, let's go now to SpaceX in Hawthorne, California, where Jesse Anderson is live as we await that second burn. Jesse.
Thanks, Daryl. We are actually currently, as you can see on your screen, in that second burn, SES-2, here right now. This burn is a very short burn. And we've got live views of the NVAC engine there ignited on your screen, again carrying the 2 lunar payloads on Falcon 9's second stage. This burn will last just over a minute long. And this MVAC engine, the thrust on the MVAC engine is about 220,000 pounds of thrust. So even though this burn is only a minute long, it provides a lot of thrust for the vehicle to carry those payloads to its targeted drop-off orbit. Again, this is the second of 3 burns that were in for the MVAC engine for this mission today. We are coming up on the
nominal orbit insertion.
Perfect timing. We have the conclusion that is SECO-2 of that MVAC engine burn, and we also heard that call out for a confirmation of good orbit. So it looks like we are on track for the first payload separation in just a few minutes from now. Now, if you're just now joining us, we have just had SES-2 and SECO-2. That's the second of 3 burns for the MVAC engine. And it's been a great launch so far. Next, we have the deployment of Blue Ghost coming up here in just about 4 minutes from now. And once deployed into a lunar transfer orbit, the Blue Ghost lander will begin its approximate 45-day journey to the moon, where it will land on the Mare Crisium for NASA's payloads to perform numerous science and technology demonstrations, including lunar subsurface drilling, sample collection, and X-ray imaging of Earth's magnetic field to advance research for human missions on the moon and provide insights into how space weather impacts the planet. So very exciting coming up here. Again, Blue Ghost deployment is coming up in just under 4 minutes from now. And just to recap the mission so far, we had an on-time liftoff at 1:11 a.m. Eastern Time. And everything has been proceeding nominally. We had a good stage separation, which occurred about 2.5 minutes into flight. That was followed by a successful landing of Falcon 9's first stage on a drone ship. Just read the instructions. And that was also the 5th flight and landing for the specific booster that supported tonight's mission. And for those of you following along, that booster also supported NASA's Crew 9 mission, RRT-1, as well as 2 other Starlink missions. Now, just before the T+8 minute mark, we had a successful second engine cutoff for SECO-1, and that was also followed by a confirmation of a good orbital insertion. And that was the first burn of the second stage engine. The second one, again, just completed just a few moments ago. Now, the vehicle is currently coasting with the payloads attached. And we are a couple minutes away from the first deployment of our first spacecraft. Again, that will be Blue Ghost. And there you can see an awesome live view of the Blue Ghost spacecraft on board Falcon 9's second stage. And we're just about 2.5 minutes from deploy of Blue Ghost. And this is a cool view. We do have the canister just below that spacecraft protecting iSpace's payload there. So we do have 2 payloads on board. But again, the next milestone coming up is that separation of Firefly's Blue Ghost lunar lander. Just as a reminder, once Blue Ghost is deployed from Falcon 9's second stage, it will have about a 45-day journey on its way to the moon, and then it will have about 14 days of lunar surface exploration. So this is a pretty exciting mission. Very excited to see the spacecraft begin its journey here in just about 1.5 minutes. And once again, there you can see a live view of Blue Ghost there on your screen, still attached to Falcon 9's second stage. We're anticipating deployment in just about a minute from now. I'm getting some really awesome, cool views. This is looking aft at the MVAC engine with a beautiful Earth in the background. These lunar missions are really cool because the Falcon 9 vehicle gets to get really far away from Earth, and we get these awesome Earth views. We are approaching deployment of Firefly's Blue Ghost here in just about 30 seconds. With these live views that you're seeing here, we should be able to get a really good view of deployment here coming up in about 10 seconds or so.
Firefly Blue Ghost, separation confirmed.
And there you can see, and you also heard the call out for confirmation that Blue Ghost is drifting away from Falcon 9's second stage. From all of us here at SpaceX, it has been a pleasure having you on board, Blue Ghost. Safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services initiative to deliver science and technology to the lunar surface. And we want to thank Firefly for entrusting us with today's historic
Operation.
All right, thank you very much, Jesse. And
so head over to NASA if you're looking, if you'd like to continue the journey to acquisition of signal, which should be coming up here shortly. Stick with us here on X to continue on to the deploy of our secondary payload, the iSpace Resilience Lander. We're going into a short coast phase, and we'll be back here in just a few minutes at T plus 1 hour and 10 minutes for deploy of the canister, which Resilience is safely nested inside at this moment. Then at about T plus 1 hour and 26 minutes, we'll have the third restart of that MVAC engine, SES-3, and then shortly after that, deployment of the iSpace Resilience Lander at T plus 32 minutes. We'll see you back here in a few minutes. Welcome back. If you're just now joining us, Falcon 9's second stage is preparing to deploy the iSpace Resilience Lunar Lander. Now, before we can do that, we must jettison the payload canister, which is currently encapsulating the Resilience spacecraft. Now, this canister was needed to protect Resilience from Blue Ghost, which was previously sitting above it during launch. And it also took the launch load of the Firefly spacecraft and transferred it to the rocket structure. Now, canister deploy should be coming up here in just about 10 seconds or so from now. Apologies, we actually have about another minute before we expect to deploy the canister. Once again, this was an important structure that needed to be added to the spacecraft in order to be able to launch both of these lunar landers today. We're about 10 seconds away from canister deploy.
Upper MPC separation confirmed.
And great call out. We have confirmation of canister deploy. Now with that, we're going to take another short break and return here for the third relight of the MVAC engine on the second stage, and then finally deployment of the Resilience lander. We'll see you back here in about 12 minutes. Welcome back to the live webcast as we prepare to deploy iSpace's Resilience Lunar Lander. Now we are just moments away from the third relight of our MVAC engine, and that will be followed by another short coast and then deployment of the iSpace Resilience Lunar Lander. Now this burn coming up is going to be a very quick burn. It's just going to be about 1 second long. And then it will be followed by SECO 3, that is second stage engine cutoff. And we're just about 30 seconds away from that burn. And in the meantime, we do have some live views there. This is looking aft at our MVAC engine. And this is just a 1 second burn. It might not look like much when we do have SES 3, but it will be quick and just enough, exactly what we'll need to get the payload to its targeted drop-off orbit. And there you could see we just had SES 3 as well as SECO 3, very quick third and final burn for this MVAC engine. And we are just waiting confirmation of good orbital insertion.
Nominal deorbit burn.
We got a good call.
Burn 3, not deorbit.
We got a good call for a nominal burn of that MVAC engine. And with that, it looks like we are on track for payload separation in just a few minutes. We'll see you back here at T plus 1 hour and 31 minutes. Thanks for joining us for our last portion of the mission today. We are just moments away from deployment of the iSpace Resilience Lunar Lander, which is expected to happen at about T plus 1 hour and 32 minutes, so just under 2 minutes from now. Now, Resilience is carrying 6 payloads. Among those payloads is a micro rover called Tenacious. And during its journey to the moon, the lander will conduct a lunar flyby, and this will be the first by a commercial lunar lander, which is pretty exciting. Resilience's journey is expected to take about 4 to 5 months before it reaches the moon, and after that it will set down in the Mare Frigoris, where it will explore the lunar surface. Now we are just about a minute and 40 seconds away from payload deploy of the Resilience lunar lander. And so far we have had a great mission. We had an on-time liftoff at 1:11 a.m. Eastern Time. We had a good separation of the first stage from the second stage vehicle. First stage landed back on just read the instructions. And now the second stage, carrying the iSpace Resilience lunar lander, has already completed its 3 MVAC burns. And again, we're just a minute away from deployment of this lunar lander. If you're just now joining us, we're just under 40 seconds from payload deploy of the iSpace Resilience lunar lander. We do have some live views there. This is looking forward, where the payload will be deployed. iSpace's Resilience lunar lander should be deployed here in just a few seconds.
iSpace Resilience, separation confirmed.
And there it goes. You can see Resilience slowly moving away from Falcon 9's second stage as it begins its journey to the moon. And that brings our coverage of today's mission to a close. We'd like to thank our customers Firefly and iSpace for their trust in us. We'd also like to thank the Eastern Range and the FAA for their ongoing support of our missions. This was our 8th launch of 2025, and we're gearing up for another busy year of Falcon launches and Starship flight tests. Check spacex.com/launches and follow us at SpaceX on X for updates. Until next time, have a great night.